Okay, everyone, we're going to look at a few examples, I think 3 of them, on simplifying expressions involving exponents. Make sure you review in your textbook all the various properties of exponents. There are multiple properties that you should know, and I'll be employing some of those properties, utilizing those properties here. And I've decided to look at some that contain negative exponents, some that contain rational exponents, which means fractions, and multiple operations that are going on to get to the final conclusion. But usually the directions would say simplify the expression. They would also say assume all variables represent positive real numbers, and then express your answer with only positive exponents. So I don't have the complete instructions here, I just have simplify. But it's assumed that variables will represent positive real numbers and that we only want positive exponents in the end. Okay, so first thing here, we have two products in parentheses raised to exponents. So what I mean, this 4 to the negative 1 times x cubed, that's actually a product. It's 4 to the negative 1 times x cubed. That's in parentheses raised to the negative 2 power. So what we want to do is we want to raise each of those factors to the negative 2 power. So we want to raise this 4 to the negative 1 to the negative 2. We also want to raise this x cubed to the negative 2. In a way, we are distributing this negative 2 right here. We're giving it to that, and we're giving it to that. We're raising each of those factors to the negative 2 power. We're going to do the exact same thing over here. We're going to take this 4, and we're going to raise 3 to the 4th, and we're also going to raise x to the negative 3rd to the 4th. Okay, now, I just applied a property, ab to the m equals a to the m, b to the m. You may have seen that before. All right, now, let's keep going. Notice here we have a power of a power. We also have a power of a power here. We actually do here. That 3 is raised to the first power, and we also have a power of a power here. Now, maybe you've seen this. A to the m raised to the n equals a to the m times n. So we're going to multiply. So this 4 negative 1 times negative 2 is positive 2. This x, 3 times negative 2, negative 6. This 3 just becomes 3 to the 4th. And then this x, negative 3 times 4, is negative 12. Okay, now there's actually 2 ways that you can proceed here. Let's put everything that, since this really means we're multiplying 4 different factors here, kind of group things accordingly. Now there's also a property that says a to the m times a to the n equals a to the m plus n. So that would be applied here. These powers have the same base. X to the negative 6 times x to the negative 12. They have the same base. So we're going to write it as a single base, x, but then raised to the whatever negative 6 plus negative 12 is. That's negative 18. Okay, now let's work these out a little bit more. 4 squared is 16. 3 to the 4th is 81. And we have a times x to the negative 18. So we need to figure out what 16 times 81 is. Oops, I keep doing that. 81 times 16. So we'll work this out here. You'll probably use your calculator, but I always like trying to work things out by hand. So 8 times 6 is 48. And then it's just going to be an 81 there. 6, 9, 8, 9, 10, 11, 12. 1296. Okay, so now we have 1296 x to the negative 18. But the directions are going to say don't leave answers with any negative exponents. Answers should only have positive exponents. So you may have also seen this property, a to the negative n equals 1 over a to the n. So you could think of this as over 1 if you wanted to. Now this power with the negative exponent, that's going to actually move down to our denominator. And when you do that, so you keep the 1296 on top, when you do that, you get a positive exponent. It changes sign. See right here? Went from a to the negative n to a to the positive n. Alright, so that's our answer, simplified, with leaving our answer with only positive exponents. Okay, another example. And notice I did this with the fraction exponents, because a lot of people don't like fractions for some reason. So what we're going to do is we're going to use distributive property here. So we have 3x to the 3 halves times the expression, the quantity, 2x to the negative 3 halves plus x to the 3 halves. Alright, now, whenever you use distributive property, and you have the same variable like we do here, x to the 3 halves and x to the negative 3 halves, they're all x's, you add those exponents. So first we do the 3 times 2, 6. Now, I'm going to actually write this out, what I need to do. The x's are going to get combined, and we're going to do 3 halves plus negative 3 halves. Because we're actually multiplying x to the 3 halves times x to the negative 3 halves. So the rule when you multiply powers with the same base, you're supposed to add the exponents. Okay, now this 3, remember there's a 1 right here, 3 times 1, that's going to become a 3. And now x, well, we're going to add the exponents. So 3 halves plus 3 halves. So it's raised to that. Okay, now we get 6x, 3 halves plus negative 3 halves, that's 0. Plus 3x, 3 halves plus 3 halves, that's 6 halves. Okay, now, x to the 0 is just 1. So 6 times 1, 6 divided by 2 is 3. So we actually get 6 plus 3x cubed. You can leave it like that, or you can write 3x cubed plus 6 if you were going to write it in descending order, which means the exponents are highest to lowest. Okay, so that's a good example. And then the last example, look at that. Simplify the expression. C to the 1/2 raised to the 3rd times d cubed raised to the 1/2 all over c cubed raised to the 1/4 times d to the 1/4 cubed. Okay, first thing, apply this power of a power property, meaning we have to multiply. We're going to do this for every single one of these. So you want to get rid of those parentheses first. So we're going to be multiplying, and this is like over 1. So we're doing 1/2 times 3 over 1. So this is going to be equal to c to the 3 halves. D to the 3 halves, because this is like over 1. 3 times 1 is 1. 1 times 2 is 2. So we're multiplying. So see, let me kind of just show you if you're a little stuck here. We're doing 1/2 times 3 over 1. That's 3 over 2. Over here, we're doing 3 over 1 times 1/2. That's 3 over 2. Okay, so this is like having an over 1. This is like having over 1 as well. Kind of a strange problem the way they have this set up, but we'll deal with it. Okay, now here, 3 over 1 times 1/4 is 3/4. And then the d, 1/4 times 3, 3/4. Now, it doesn't always work out where all the exponents are exactly the same, but the concept is to multiply there. All right, now, here we have a quotient with the same base and another quotient with the same base. You may have seen a property, a to the m over a to the n equals a to the m minus n. So we're going to be subtracting these exponents. So this is going to be c to the 3 halves minus 3/4 and d to the 3 halves minus 3/4. Now, when you add or subtract exponents, you need the same denominators. So we have to do 3 halves minus 3/4. And we're doing that for both of these, so it's going to be the same answer. So let's just do that off to the side. So we need a denominator of 4. So it's really going to be 6/4 minus 3/4. And now we can subtract these numerators here. 6 minus 3 is 3. So we get 3/4. So we're going to get a 3/4 for each of those exponents. So c to the 3/4, d to the 3/4. We do not have any negative exponents, so we're good to go. We're all set. You can leave your answer like that.